Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Iszi Lawrence. On this week's episode, we talk to Andre Rowe about Tyrannosaur skulls and what makes a great B-movie.
Hello, everybody, and welcome to Terrible Lizards. Thank you very much for being alive and listening to this programme. Unlike all of the dinosaurs who died before this was created, not the birds, as a caveat to the pedants, I have with me on the opposite end of the internet is the magnificent, from Queen Mary University, Dr. Dave Hone. Yeah.
Not feeling particularly magnificent, but thank you. I'll take it.
Well, you know, you don't need to be magnificent because we've got a guest on this week, do we not, Dave?
We do. So this week we have Andre Rowe, who I first met, I think, at the Natural History Museum conference just last year in, wherever it was, January, I think, for the 200th anniversary of Megalosaurus stuff. Though I had come across his research before. In fact, I think worryingly for him, I'd reviewed several of his Tyrannosaur papers.
Ooh, fight!
Yes. But yeah, so I keep saying we keep getting talk more about Tyrannosaurs. It's like I talk about Tyrannosaurs all the time. I wrote a book about Tyrannosaurs. I'm kind of bored of talking about Tyrannosaurs. So here's someone else who can talk about Tyrannosaurs that's not me, which is the ideal solution. And also, I think fairly unusually, having crossed the pond from America to the UK, because a few people go the other way, but not so many come over here. So, yes, here is Andre, who's currently at University of Bristol. Ding.
Yep, thanks for having me, Dave.
That's the cue.
Yeah.
Sorry, I think slight internet delay really ruined that.
It's all good. No, great having me. Thanks for having me here, guys. I appreciate it. Yes, you're right, Dave. It was the 200th anniversary of Megalosaurus that we first spoke. That was a nice conference. I really liked the talks there. I think my talk was a bit goofy. I was also very jet-lagged. So I had flown back from Wisconsin, I think a couple days prior. And then I had jet lag, 6-hour difference. And then I'd take the bus to London. And then it was like, here you go give your talk. I was like, all right. It was a fun one. I remember I ended up at the pub with my friend Suresh Singh, and it was just a little lunchtime break. I was just going to get some food and chill out. And I saw a sign, and it said, 3 shots for 10 quid. I thought, this is London. That's really nice. So then I went and got 3 shots.
That's a good deal.
That's very good.
3 shots. And then I thought I'd get a pint to go with that, because, yeah, you know, whatever. I live to live. And they misheard me, and they gave me 2 pints. And I thought, you know what? It's fine.
Ooh.
I can handle this. So then I sat down, and I went through all my drinks, and I thought, all right, time to head back to the conference. And then Suresh showed up. He was a little late. I was like, oh, man, I can't just leave now. I have to drink with Suresh. So then I got another order of shots and another pint. And then I stumbled back to the conference. And then, yeah, I had to go on, and I think 2 hours I had to talk. I remember going up to the stage.
Amazing.
And Susie Mamet was calling for flash drives for the next speakers. And I went up to her, and I'm thinking, okay, you know, just act natural, act normal. It's fine. I go up to her. I'm like, what up, dog? And she just looks at me. Good times.
That was good. Do you remember anything about your talk or what the subject was?
Or indeed the conference as a whole.
No, I mean, I don't mind. But I want to know how the talk went. I think this is great.
No, the talk was fine. I went up, and it was a lot of my kind of a summation of the PhD work I did at the University of Bristol with Emily Rayfield and Mike Benton. So we studied body size acquisition in big theropods. So different lineages of theropods got gigantic around similar time periods. So the megalosauroids, tyrannosauroids, a lot of really popular dinosaurs just all seem to get big, and they're all big bipeds. So that was kind of the clincher for all my work was, how does being a big biped influence feeding mechanics? How does it influence what's going on with the skull? And we can test it using a lot of the tools that Emily Rayfield is known for now. So FEA, finite element analysis, so engineering tools. So getting to Bristol, did my talk on it, and I remember talking about how I almost got into a fight at Milwaukee Public Museum with one of the security people, and to the point where we were getting food later, and then Steve Brusatti and Darren H. came up to me, and they were like, wow, that was amazing. And I was like, oh, that's so sweet. And I was showing off my Elvira tattoo, and Darren H. was like, is that Elvira? I was like, it is. So, good times. Good times. From what I remember, good times.
Amazing. Must have been. It must have been. Otherwise, you'd remember if they were bad. I mean,
exactly.
Logically.
That's exactly what I tell myself.
I'm gonna ask you a question because I'm interested now. why did all of these big dinosaurs get really big and bipedal? And why did they do it around the sort of same time? And when was that time? That was like several questions, but can you talk about that, pleplease?
No, that's all good.
Elaborate on the previous sentence, I think.
Yes. Yeah, not about the drink.
I mean, I can do that, but no, those are some really complex questions. I have read some work. I know some of the big hypotheses concern climate or competition from other species, or there's Cope's rule, which is a tendency for certain vertebrates to get bigger over time. It's not really a law or a theory. It's just kind of this observation that different groups grow through. But I don't think there's a clear-cut answer in terms of a lot of these different vertebrate groups. I more was so interested in kind of the mechanical consequences of all these dinosaurs getting big, and if it would have been the same for these different groups. And a lot of it was in, I want to say, the early kind of mid-Cretaceous for the groups that I mentioned. So Tyrannosaurs, Spinosaurs, Carcharodontosaurs, a lot of the big boys doing it around the same time. They're not sympatric, they're not overlapping. So that is key to keep in mind. Oh yeah, there's some geographic distance. But they all just kind of get big, and they have a very similar body plan. And I just thought it was a cool subject to kind of look at, because we have complete skull material for a lot of the different genera in these groups. And they're amenable to different types of scanning. So the University of Bristol is a surface scanner, which I took around the world. It was kind of attached to my arm at a certain point. It was like the Blades of Chaos from God of War. It was just permanently just seared into my arm. So I was going around just scanning these skulls and reconstructing their anatomy. So that was another big clincher, was we have the tools to study and quantify all this stuff, which would have been nearly impossible decades ago.
So the questions you're trying to answer is what will happen to their skulls and the mechanics of their anatomy as a consequence of them getting larger. So, I mean, why isn't it exactly the same if they were smaller? What's changing that they might need to adapt and acquire different, anatomical parts for them to be able to cope with this? Or grow anatomical parts.
Yep, there was the size component, and then there's also the influence of shape as well, which is surprisingly easy to test if you equalize the scaling of the different skulls or account for size differences. Then we're just left with the shape, because even if Spinosaurs and Tyrannosaurs all get big and kind of roughly around the same time, they still look quite different. Spinosaurs have that kind of crocodilian morphology to them. They have that really elongated rostra, and the Tyrannosaurs, they're like me. They're just as broad as they are tall. Yeah, that's why. I remember saying that when I gave my talk at the NHM. I said, I said something like I have a lot of common in theropods. These big theropods were big carnivores that eat anything, whereas as wide as we are tall. Well, that's how the Tyrannosaurs are. They just have these very blocky skulls. When you look at them head on, you have Acrocanthosaurus or Giganotosaurus, and it's like, you'd think they'd look similar from like, if you're looking them dead on, but you really don't. They've got these kind of relatively slender body plans. But T.rex, I mean, just wide, really wide skull.
Like a bulldog.
Yeah, I remember seeing that exact thing when I was in, Tokyo was the first time I encountered, one of the really big Carcharodontosaurs, and they had a skull of, I think it was Carcharodontosaurus next to a T.rex. And I've got a photo of it on my blog somewhere. And side to side, they basically look the same. And then you go around the front and one is like 5 or 6 times the width of the other. And of course, you never see that. Every illustration is always the nice big side view, so you could really see the shape and all the teeth and the eye, because that's what everyone wants to see. And of course, given how it's preserved, that's by far the easiest way to show it anyway. But it is one of those like light bulb moments when I saw it head on, and you're like, oh, that is, I knew it was thin, but I thought it was like 2/3 the width. And it's like, no, it's less than 1/3 of it. It is unbelievably narrow.
It's a really striking difference. Yeah, it's a really striking difference. I noticed it's like, kind of had that light bulb moment too.
Yeah.
Where
I've just realized it's almost literally like the flat of your hand versus a fist. It's
yes.
Wow.
Yes, that's a good analogy for it.
And from an amateur idiot question, this isn't just because, the rock compressed the skulls and so they look thinner.
Nope, they're just unbelievably narrow.
This is the actual morphology of the skulls.
Why would, could that be, for me, it would be like, well, that would be really useful for running through trees. What, is it just because the stuff that they're eating? Why would they need to be like thin and narrow? What's the advantage of that compared to being really chunky?
Well, we're actually shopping around to submit a paper kind of concerning that. So I won't get into a huge amount of detail, exclusive content, but we've kind of, it comes down to, a lot of it is the musculature, is kind of the big one. So if you're a big T-Rex, basically you're kind of sacrificing some of your, I guess you could say, integrity of the skull. You're risking more of more breakage, more mechanical breakage. You're reaching these structural extremes, but in exchange, you're achieving these ridiculous bite forces associated with being that big. So
being narrow is more like sound.
It's one of those ones that's almost just an inevitable consequence of shape. In that, if you remember, or listeners remember, so dinosaurs and reptiles as a whole, fundamentally different to us. When you squeeze your cheeks, you feel your muscles because our face muscles and our jaw closing muscles are outside the head, whereas theirs fundamentally sit inside the head. So if you have a very narrow head and then there's already the brain case in there, there is only so much space for muscle. So not that, of course, animals choose to evolve any particular way, but like if you want to have more muscle in there, you can't just pack it on the outside. The only way you can do that is to make the head bigger. So if you're going to have an animal with a strong bite force, the head is going to have to be wide just to accommodate the musculature. So fundamentally, you're going to have that split, whatever else is going on. So a high bite force must have a wide skull if it's a dinosaur, whereas with a mammal, not necessarily, depending on quite where you put them.
So that was one of the big questions we had. So I did my master's in La Crosse, which is West Wisconsin. It was UW La Crosse. I worked with Eric Snively, who's now at Oklahoma State University.
I know Eric.
I know you. Eric's great. One of my favorite people in the world. But my master's project was essentially studying bite force differences and mechanical stresses in the skulls of these Tyrannosaurs at different growth stages. So we had Sue, the big adult T-Rex, at the Field Museum in Chicago. We had Jane. We had CT scans of Jane's jaw. Jane is an adolescent T-Rex, also in Illinois. And then we had Raptorex, which is a juvenile tyrannosaurid from Mongolia, about 3 to 6 years old. So we had this kind of growth series of tyrannosaurids. And so we were studying the bite mechanics and bite forces, basically as the T-Rex, as a hypothetical T-Rex gets older, how its feeding strategies would change, potentially, and the mechanical behavior of the skull and the jaws. So that was what we found. That was kind of our big finding out of all of them, was as T-Rex gets bigger, we thought it would be overall less stressed in the jaw. And it's actually not, in terms of absolute stresses acting on the jaw, it's the greatest in T-Rex as it gets bigger. Whereas in Raptorex, it's not much of a risk of breakage. So that was kind of our big finding, was that, in terms of predatory behavior, T-Rex is kind of adult T-Rex is acting kind of on the outer limits of stresses and in terms of mechanical breakage. And it was probably subduing prey in like a single bite with these massive jaws that it's known for. Whereas juveniles, they don't have that bite force. They don't have that risk of mechanical breakage. It's not as present. So, and given the more agile physiology, they're probably more like, I always say to people in pubs, because I go to pubs a lot, I compare it to the Jurassic Park velociraptors. They're these agile, predatory animals. It's very cool, blah, blah, blah. Whereas you have T-Rex just kind of waiting and watching before it delivers the killing bite Triceratops or whatever animal.
With that in mind, do you think these smaller ones are basically holding on? They don't have such thick teeth, although they've got much less risk of breakage. So are they biting and holding their prey rather than biting and letting go?
I think they're biting and holding, but also I think one of the keys is that they're pursuing smaller prey as well, which would be subdued from blood loss anyway. And proportionally, at this stage, their arms are actually usable compared to the body size. Yeah. So you've got more to work with as well in terms of subduing your prey. You can actually kind of grapple on and sink your teeth in or whatever. Whereas with big T-Rex, it's kind of a one swift move. You can try to, dispatch your prey. And if not, then obviously we have some evidence that, prey was getting away. like the hadrosaur, the AMNH, which has the tooth embedded in its vertebrae.
So does this mean that T-Rex was an ambush predator? So you think it was sort of waiting for sort of things to go past and then grabbing them? Or is it more of a case it was hunting, chasing things down and grabbing, just finding the one and just getting it with one attack, as it were?
I 100% lean into the ambush predator camp, where when we consider a lot of the other biomechanical studies...
They're big, though!
They are big, but they're surprisingly agile in terms of not locomotive as in running or even walking. They're actually kind of cumbersome. We have a colleague, John Hutchinson, at the Royal Vet College. He does a lot of that stuff. That's cool, but they're very swift in terms of rotational inertia. They can kind of rotate quickly. They got these spring-loaded feet. This is, again, a lot of Eric Snively's work at Oklahoma State. I guess when you consider that, the fact that they were quick on their feet, they could quickly kind of spring around and rotate and pivot. They couldn't really chase you down, but they could do that. They had this bite that can subdue mostly anything in one bite, provided it hits a vital organ or two. The evidence to me seems to be that it's functioning as an ambush predator.
So how does it hide when it's so big? Because in my head, an ambush predator is literally waiting for things to get close enough to it and getting it. But they're massive. I mean, I'm assuming that I'd spot one, down Tesco's or a supermarket or something. So how are they doing it, do you think?
I guess if you're kind of crouched and you're in a jungle or forest and you're just kind of sat there motionless and waiting, I mean, you'd be surprised what you'd miss. There's a video on YouTube that I really like of these Floridians doing Floridian things. They're kind of looking at alligators and kind of poking and prodding. And they're, kind of like in a stream bed. And the whole time the camera zooms out of the one person filming. And right there, kind of in front of them, there's just an alligator just watching them. A big boy.
Oh,
now,
God.
Don't get me wrong, it's kind of in the water, but it's just motionless. And it blends in so well with the background, and they don't notice it. I didn't notice it until, the very end of the video. So there's the fact that you have these big dinosaurs, which, we don't know what really, I'm not sure what their visual acuity would be of a triceratops, but eventually something's going to walk past. And if you're just kind of sat there motionless, there's your chance to strike.
I love this image because it's not the image I had of T-Rex being a sort of like wait and lurk and then have something going past and it's going hung.
Yeah. I mean, that's based on all the biomechanical evidence. That's kind of the image that I've got for a big T-Rex. I don't know if you have a different image in your mind, Dave.
Yep.
Okay.
I was just also going to be rude and contradict you.
Yeah. No, please do.
I mean, I've always been happy with the idea that, but again, actually based on Eric's stuff, but the efficiency of the arctometatarsal, so the compressed foot for efficiency and long distance locomotion, I've considered them much more like I had this chat with John Conway, the artist, years ago, just like a very, very slow motion version of hyenas, or we talked about how it could be hilarious to have a version of Steven Spielberg's film Duel, his first film, where it's a guy in a car just being traced by a
truck,
by a big rig truck, just like that, but happening at like 12 miles an hour rather than at 50.
Okay.
And just they've got the endurance to wear things down. I think most things are going to get away from them.
Yeah.
So I would still maintain. Sorry, for the listeners, this is going to be awful. So let me be clear about several different things that I've said at various different times. So I've long said, and I will maintain, that theropods fundamentally, there's going to be exceptions, but fundamentally they're targeting relatively small prey. A fraction of their body size, that's pretty normal. I think big tyrannosaurs like T.rex, Tarbosaurus, etc., are several steps above that, but that still means small. So I'm talking like maybe 50% of their mass, which, bear in mind, is a big animal. If it's a 7-ton T-Rex, 50% of their mass is a 3.5-ton Triceratops or a 3.5-ton hadrosaur. This is a very large animal indeed. This is an elephant, but it's still quite small compared to the actual predator, and much bigger proportionally than I think Allosaurus is taking stuff 10% of its mass or something like that. Velociraptor like 5. Very ballpark, vague arm wavy numbers. But yeah, I think something like Triceratops is probably actually a bad example, given that they're probably largely solitary as adults. But things like the other big Ceratopsians are out, and then
Hadrosaurs.
particularly hadrosaurs, which we think are in relatively large numbers. Yeah, the hyena style almost, but again in slightly slow motion. Antelope are much faster than hyenas, over 500 meters, not over 5,000. So T-Rex can just come over the horizon, basically, and everything can see it coming and everything can start moving away. But if it keeps going and keeps going and keeps going, well, they're going to get tired. And inevitably, whichever one is or has a limp, wasn't feeling very well that day, ate some dodgy saplings or whatever it may be, or is still recovering from the last T-Rex attack, the one that starts to lag behind is going to be the one that's getting chomped. And that's my main kind of mental picture of them. The other thing, which actually goes back to what he said, which I put in my T-Rex book, and to my knowledge, it was not a truly novel observation, but I think it's the first time anyone actually really said it, and I'm genuinely surprised no one's picked it up, is I think they're nocturnal, which then partly covers her question of how do you hide this thing, which actually works for both your model and mine, because it's still an issue. I've said before, you can be the longest distance wolf-like runner that you like, but it still helps if you start half the distance away that you could do if they saw you coming from further out. T-Rex has massive, massive eyeballs. That really helps if it's dark. And it's really, really big, which means it's going to overheat if it tries running around in the sun. So don't run around at night when you can see well, and other things probably can't see you quite as well. And that that'll make up at least some of that distance. But the other thing, as ever to say, of course, is that the two things we've just said are not mutually exclusive. I know but for the audience, the Spinosaurus stuff is I maintain that actually Spinosaurus could probably swim. I just don't think that's really how it's hunting. But that doesn't rule out, indeed, the paper I did with Tom Holtz. We said standing at the edge of the shore and kind of pushing off with your feet and thrashing the tail and really going is probably quite an effective way of getting stuff. Right. So, a pseudo swimming after stuff model for Spinosaurus, we don't rule it out. We're more than happy with it. And if it lives in a forested environment, sitting very still near some water is probably a great strategy. But if it's out in the coastal plains, and we know at least some of them where there's not that much tree cover around, just sitting and hoping something walks past is probably not impossible, but for a large chunk of the year, it's likely going to be a challenge. And so there's no reason they can't do both. And then the question becomes, are they better adapted to one or other of the three things that we've said? Or is it context dependent? Or is that shift as they get older? Or is that shift with the environment? Or is that shift with the season? Or is that shift with the prey species? Because you watch lions in Botswana that are chest deep in water, and they are hunting very differently to the ones in Namibia that are only 100 miles away, where trees basically don't exist. They're so completely different alien environments. And yet both of those are completely different to the classic Masai Mara, Serengeti or Kruger, where the grass is 3 foot high and lions can just walk around quite happily and nothing except giraffe and elephant can see them. So, but being one animal doesn't mean you do one thing.
Right. That's something that happens a lot in paleo, I think, which I'm probably guilty of as well, is that we're very black and white sometimes, I think, in terms of how we assign these different models to the animals. I think a lot of paleontologists do take more time to actually study extant species.
I can highly recommend a book on dinosaur behavior where we.
I have another question though that you and Dave can argue about, because Dave, I think, recently wrote a paper. You've basically said that from what I've heard and understood, so you might not have said this, but you basically said there is a limitation to the size of head that a T-Rex can have, because if it gets any bigger, the actual structure of the skull will cause it to injure itself, 9 times out of 10 if it tries to bite anything big. So does that mean that there is a definite limit in your mind to the actual size that the actual animal can get to? Because there's no point in being any bigger if your head stays the same size.
Oh, God, that's what we could go on for days.
You saying he said
No, I'm saying Andre said that, because you say they could get way bigger than they actually are. And if there's a structural reason why they can't, that's interesting.
Right, yes. I see.
They can definitely get bigger. I don't think we've ever uncovered the actual biological limit in terms of the species or the individuals that we found. But that is a valid question of how big, a bipedal animal or a quadrupedal animal could get. I mean, I guess in terms of absolute body size and the sauropods, I mean, those things, I'd look to them first.
Yeah, they're massive.
Yeah. So in the paper I did with Jordan Mallon on this, so we had what we considered our very hypothetical with lots of caveats and estimates, but our limit came to something like 15 tons. And that's actually about what the sauropods get to when you factor in that they're quadrupeds, but they usually have 3 feet on the ground, means that you actually average up with about 30 tons maybe being taken on 1 foot if that animal is moving relatively quickly. And so I can't remember the exact calculations, but it did turn out potentially not by chance, that is actually a coincident point, that basically you hit that limit and that our 15 tons maybe is quite a good estimate. But as we say in that paper, it's like we don't think a 15-ton T-Rex is necessarily doing what a 7-ton T-Rex does, because they're not really the same animal anymore. This is the whole niche thing. And again, goes back to exactly what Andre was just saying about a half-size T-Rex. I mean, I know various people, including Tom Holtz, have written these papers about niche shifting. I've talked about in pterosaurs and other things, and it's well understood in crocodiles, but this is absolutely what's going on. A 1 meter long crocodile is not eating things in the way that even a 3 meter one is, let alone one of these 5+ meter monsters. They just simply biomechanically operate differently, even if you just scale them up, even if one is just literally twice as long and twice as wide and twice as deep and everything's twice as big. Square cube laws and things start kicking in, and they won't be the same animal. And particularly when it comes to prey size, which is usually very closely correlated to body size. Yeah, a 15-ton T-Rex. I mean, at that point, maybe the issue is, no, it can not barely move, but it's actually going to be rather slower and more cumbersome. But if it's now big enough that it can tackle 10-ton hadrosaurs, well, they ain't going to be quick either. And then it really does become like the slow motion car chase, because this is what I think people always think is like, you've got to be super fast to avoid predators, or as a predator, you've got to be super fast to catch prey. It's like, no, you just need to be slightly faster. That's really the limit. There are predatory snails that hunt other snails, and by snail standards, they're really quick. But I'd be happy to race them, and indeed, almost any other invertebrate would beat them in a race.
There is the best horror movie I think we've got. I think that'd be amazing. Giant predatory snails.
There's a horror story short. I remember it we're getting off topic, but there was a compilation of like horror story shorts that I remember reading as a kid, like 10, 11, including Ray Bradbury and a bunch of classics. And there's this, entomologist on an island where he discovers these giant snails, like 5-meter high shells, and they're predatory, and he ends up being killed and eaten by one. It's quite grim.
They were also predated by, if you look at bestiaries from medieval times, they often have in the marginalia snails killing and eating people, as well as rabbits, just to prove Monty Python's Holy Grail is correct.
The rabbits I knew about. I didn't know about the snails. That's
snails too.
Yes. And there was was it 70s or 80s B-movie horror movie called Slugs?
I liked that one.
But they're normal size slugs.
I've seen that one.
I remember catching a clip of it, and I know it's B-movie, but it is absolutely literally, they've just got like a supermarket conveyor belt and stuck hundreds of model slugs from like a joke shop on it, and it's just running, and this is the shot of them moving in mass, and of course it is unbelievably unconvincing.
Yep. Good movie though. I enjoyed it.
Have you seen it?
I have seen it.
Wow. Okay.
Of
I
course.
love my crap horror movies. I know exactly which it takes place on like Louisiana. It's like southern USA. I know that one. I remember the girl wakes up and she's covered in slugs in her bed. Yeah.
Yeah, and that's the thing. The falling asleep bit I can get, but apart from that, as a horror movie protagonist, is like, I'll walk away slowly. Oh, I've escaped.
Similar story. If you've watched Night of the Big Heat, which is a Hammer horror one, it's got Peter Cushing, Christopher Lee in it, and it's really good. It's like proper, the monster's coming, you don't know what it is. And in the end, they've obviously spent all the budget on the actors, because at the end of it, they reveal the monster, and it's literally a bin liner on the floor. It's like, guys. Yep. But anyway, we're off the topic of tyrannosaurs and big, scary theropods.
Oh, we're doing horror movies. This is prime Elvira material. Did I ever tell you that story, Dave? It is. It's important. When I met Elvira, I met her 2 years ago, the actual actress, Cassandra Peterson, at Comic-Con in Kansas City. And as you've seen, Dave, I'm covered in dinosaur tattoos. I've got Pteranodon.
Yeah, I know you got loads of tats, yeah.
I went up to go meet her, and she saw the tattoos, and she's big on animals and everything. She was like, "Oh, those are really nice." And I was like, "Oh my gosh, well, you'll really like this one then." So then I show her my sleeves, and she can see my Elvira tattoo, because I was waiting my whole life for that moment. And she says, "Oh, well, it's appropriate you have that one, because I'm kind of a dinosaur now too." She's 72. And I said,
Yeah.
what do you mean? You're like my age. What, you're like 28, 29? And she was like, "Yeah, okay." She was really sweet. She was just such a sweetheart.
I'd have been amazed if she'd rolled her sleeve up and she had a tattoo of you. Now, that would have been unexpected.
That would have been a story. Yeah. I don't think she's as big a fan of me as I am of her. That's just how it goes, though.
That's because she hasn't listened to the podcast yet. We'll get there.
Yeah.
So,
please do.
So talk me through. Let's get to how do you do the sort of research where you are actually measuring the skulls, working out how they can cope. Is this all computer modeling? Are you actually making things to sort of like show the different forces on a skull? What's going on? How's you actually doing this research?
Yeah, good question. Well, a lot of it is digital paleo, which luckily I've had a little refresher on because I flew to South America on Saturday, and I'll be there for about 19 days.
Oh, wow.
We're doing a whole mini workshop for students of our colleagues in Brazil and Argentina, so that should be something. You'd think I'd have packed for that by now, but I haven't. Anyway, a lot of it comes down to 3D modeling of the skeletal material. So our kind of goal is to reflect biological reality in terms of these models that we make. And a lot of the previous limitations when it comes to big dinosaurs was you had to use CT scanning. So people think of CT scanning in the medical usage. But it's been applied to a lot of different fields now, like paleontology and anthropology, zoology, you name it. You can scan it, and it's nice because it's non-destructive, so we're not breaking up any of this invaluable material. And we can see the interiors, and we can reconstruct the anatomy accurately. So problem is, when you have animals like T.rex, they just get so big that it becomes impossible or very costly and difficult. So luckily, when I was doing my master's with Eric Snively, he had CT data already of the jaws of these different tyrannosaurs. So we were able to apply finite element analysis, which is a big engineering tool now in paleo and in zoology and in various fields where we can test for stresses and strains acting on any sort of 3D object if you apply whatever forces you want, really. So usually we'll apply, X amount of newtons acting on the teeth. And then it's like, how does the rest of the jaw respond to that appropriately when we load our jaw? So I want to simulate soothe T.rex. I want to simulate it biting into that hadrosaur, the one that got away. Yeah, the one that got away. That's going to be the name of my book. No, it's biting into this hadrosaur and it gets away. Well, what kind of forces are acting on the jaw? And then what are the resultant stresses on the jaw? Now, something else I have to explain is that when we're making these models, it's just a bone. So a key component is also the musculature of the animal when it was alive. And basically, that's when it gets a bit more difficult. So a lot of people have mapped this stuff out already. So Casey Holliday in Mizzou, a lot of his career has been mapping out muscles in extinct reptiles like dinosaurs. So we consult a lot of that type of data to apply these muscle forces that would be acting on the jaw, and then we can get bite forces, we can get these colorful displays of stresses. We can see where the stresses on a jaw would have been the greatest, where the jaw would have been the strongest, and we can compare these quantitatively to other jaws of different clades. So it can compare, Tyrannosaurus versus Spinosaurus, if they're both biting and applying some amount of newtons of, the same amount of forces to the prey that it's trying to eat. So that was basically my master's work, was quantifying feeding and behaviors and mechanical stresses in T.rex with respect to growth. And then my PhD work did at the University of Bristol. I met Emily Rayfield at SVP in it was Albuquerque 2018. And yeah, it was fun times. I met her at the museum and just kind of instantly clicked. I have no idea what that lady sees in me. I don't ask. I just kind of let it just kind of let it be. I told her yesterday that I was going to be on this podcast, and I immediately was like, "Yeah, I'm just going to make fun of you for an hour." Emily, if you're listening to this, you're the best. Thank you for everything. But yeah,
we had to edit a lot
Bristol.
out. I'll tell her that.
Yeah.
But went to Bristol. Worked with Emily and Mike, and they have a surface scanner, so I was able to go and just go to all these different museums and scan these different big theropods and compare them all together and see if body size has identical effects on feeding or if it varies by clade or what have you. And it was fun. It was fun for the most part. I moved here. I've lived in Bristol for the last 6 years now. I moved here in September 2019.
Oh, wow, yeah. So you went straight into COVID. Lovely.
I moved here. I was just getting acclimated to everything. It's my first time that I ever left the States. So I came to Britain. I was like, wow, this is great. And the first thing was like, first week I was there, like, wow, the weather's nice. This is great. Why does everybody complain about the food's good? And then the week after that, it rained for like a week and a half straight. And I went to Tesco and got some TV dinners, and they were awful. And I was like, okay, this is all kind of making sense now. And then, I went back to Wisconsin for the holidays, as I always do. And went to the Field Museum, did some scanning, came back to Bristol, and then the whole world just went on hiatus. And I was trapped in my flat for months.
But with scans.
I had scans, and there was another silver lining. With this 3D data, it's easily shareable. So I owe a lot to various researchers who got me through the PhD work. So, I mean, for example, one of my chapters was on Tyrannosaurus specifically, because Tyrannosaurs have a comparatively good fossil record in terms of carnivorous dinosaurs, in terms of skull material available that we could test. So, I scanned something at the Field Museum. They have Pliosaurus. I scanned that, had data from Sue already, contacted the Smithsonian. They had a T.rex, the nation's T.rex. They sent it over to me. AM&H in New York, they had Aleo-Ramus, sent the data over to me. People, these various institutions had data that they hadn't tested, and they were like, times are tough. You can't come scan it. We'll either scan it for you, or we already have it. And we'll send it over. And it just kind of worked out. And I was able to remotely connect to the computers in the labs and actually run the tests. So I don't know. Things just worked out somehow. And I remember at the end of the thesis, when I was getting ready to defend, we have annual progress meetings every year. In my third year, I had Phil Donahue, and I don't remember what the conversation was exactly. We were talking about Futurama at some point, but then we got to the actual dinosaurs, and I remember that. But I said something like, I'm surprised with myself for how many skulls I managed to scan with COVID. And I said something like, me and Emily were surprised that you scanned, even without COVID, the fact that you scanned all those skulls, like all that data was still surprising. I was like, oh, all right, we'll take it.
Presumably, obviously, the more samples you've got, the more, accurate your results can be. Is there another reason? Is it just because there are so many different shapes and species that it really helps? Or is it just the fact that we've got this amount of data and this actually gives us more proof as to your findings?
I think it's a bit of both. The thing is, I want to represent each of these lineages decently enough that it actually means something. In general, there's that image with dinosaurs that we find them and they're just complete and the skull's all there, and it's like, not really. Like I said, Tyrannosaurs were a big part of it. That paper's already been out because I could get 7 individuals and compare them. But Spinosaurs, I had Baryonyx, Spinosaurus, Suchomimus, and that's about it. Get about 3. Allosaurids get about 5 or 6.
Even them, Spinosaurus is not much of a skull. Baryonyx is 2/3 of one on a good day.
Mm-hmm.
Yeah, the data is frighteningly limited for a species that group that we constantly publish on.
Right.
And then there's basically nothing of any of them. Mark and I, we've got Mark Whitten and I have a Spinosaur book coming, and Mark at one point, I think we dropped it, but basically did a general skeletal and then coloured in everything that we had for every Spinosaur, and it's still not very complete as a skeleton, to be quite honest.
I'm not too surprised. Well, I had to do some infilling myself and use data from other Spinosaurs to create composites. And even some of the museum specimens, because one of them were replicas anyway. So a big museum not even a big museum, they had a big data collection point for me. It was the Dinosaur Discovery Museum back in Wisconsin, the one that Thomas Carr is kind of the curator, I think, or the advisor for, but they just got a whole room of theropods. So that was where I had my light bulb moment, where I was looking at T.rex head on, and then 5 minutes later I'm looking at Acrocanthosaurus head on, these two big theropods, and it's like, wait, T.rex is just big, it's so wide, and then Acrocanthosaurus on a side profile, it's like, oh, this is the same size. And it's like, no, it's not. It's like the fins, the thin section of your hand, or the thin side of your hand versus their whole fist. It's like, oh, great. So yeah, it was the smaller museums like that really helped me out as well. That was something that kind of annoyed me, was some of these bigger institutions were reluctant to let in researchers. But then the smaller ones, they were willing to let researchers in. So I guess I kind of owe the PhD work to the smaller museums as well.
I think that's a fairly common phenomenon, because as someone who does a lot of zoo stuff, or at least used to, it's the same thing. Like if you contact a big institution, I think they just end up with almost like institutional inertia. Whereas small places just simply don't have that barrier. Like if you phone up and go, I have a weird question. I'm a scientist and I have a weird question and a weird favor to ask. And if you go to as I have to, like London Zoo, where I even have connections, and they're like, oh, you need to speak to this person, who says speak to that person, who says speak to that person, who says, well, we'll get back to you. And then here's a form to fill in, and here's the permissions, and this is what we want in exchange, and yada, 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 yada. And then say no. And then you phone up a much smaller institute and they go like, I'll put you on to Trevor. And then someone goes, who's this? And I go, you wouldn't know me. I'm a scientist. I'll do this. I want to know if I could do this with your animals. You're like, come next week and we'll sort it out. And like that's the phone call is, we'll do it Tuesday. Just come round and give your name at the gate. And it's like, I remember for a project years ago, they wanted, for a sauropod project I was working on, they wanted an x-ray of a camel neck, which it turned out basically just didn't exist. And I knew London Zoo had x-rayed their camels at one point. So I was like, and I've got a couple of contacts. So I spoke to them and they're like, we want like second authorship on the paper, and it's £500 for the documentation for the x-ray. And you're like, how about no to both of them? Like, this is scientific data and collaboration, and you want the second author for providing an image? And this was like it was like a 5-author combination of like 5 years.
We're not talking passport photo, Dave. It's not like take a picture of your camel. It's trying to convince a camel to get x-rayed. I think that's difficult.
They'd already done that. I just wanted the x-ray
really?
they had. Yes.
Oh,
right.
I misunderstood. I thought you were asking.
They had the x-ray. I just wanted a copy of it.
Oh, I see. I had an image of you taking 2 camels down Charing Cross.
No. This is. Can you send me the photo you've got in your folder?
Wow.
Yeah. So I can totally see that when the director is also the curator, is also the PR guy, and has final authority on the decision.
And the receptionist answering the calls.
Well, half the time, yes. It really does make a difference. So, I can totally imagine.
Yeah.
You've basically, from what I understand, because I don't know your research, Andre, this Dave thing. From what I understand, you specialise in just the anatomy of scale and the anatomy of the jaws of these different theropods, bipedal theropods, which get really big. Is there anything else that you're working on, or is there anything else I should know that you've been doing and that sort of thing?
I guess the 2 things about, I don't know, maybe 3 things. The things that I get recognized for lately, I had a really cool conversation, actually. I was walking home from work, and there's some school children who stopped me because they recognized me from the telly. They're like, oh, our teacher showed a video of you in a class. I was like, so I did a thing with David Attenborough about 2 years ago. So I guess that leads into my point, was that I'm known for the digitization stuff, the preservation of fossil scans. So we did a thing with David Attenborough on the BBC. So there was the new Pliosaur skull.
That was the big Pliosaur, I was going to say.
Yeah. So they called me down to go and make a 3D scan of the entire skull, this 2-meter-long skull. And then, I made a 3D scan of it using the very same surface scanner I used in all my PhD work to scan Tyrannosaurs and everything else. And then Emily and I calculated the muscle forces and the potential bite force range of the animal.
And was it high by any chance?
It was high. It was very high. I think we got the highest. I think it was like 65k newtons. It was comparable to a big T.rex, basically. And
Wow.
which, of course, the BBC loved to hear that. But then the day came, and Sir David came to the University of Bristol, and we were in the anatomy lab, and we were all getting set up because we had 2 interviews. I was going to talk to him, and Emily was going to talk to him, and yeah, it was nice. I just had the 3D model of it on my computer. I sat next to Sir David, and he was just asking me about, what its lifestyle was like, and what it was feeding on, and if it was the T-Rex of the seas, as the camera zoomed in on my T-Rex tattoo. And I was like, yeah, David, it's the real deal. And everyone will always ask me how he was in person, how it was meeting him. And I think any anxieties I would have had towards meeting celebrities already dissipated, because I met Elvira already, and that's like my peak. So it's like, I already met the woman of my dreams, can't really do much. But he was very nice. He was very sincere. He was very cognizant. He was very inquisitive and very genuine about everything. Because I've done 2 documentaries in the UK, and you do a lot of retakes and a lot of reshoots. They want to move the camera 2 inches that way or this way. They want you to speak up on this part or say this, whatever. And during these retakes, he turns to me and he says, Andre, you don't sound like you're from Bristol, lad. And I said, no, David, I'm from Milwaukee, Wisconsin, in the Midwest of the USA. And he says, well, what brings you to Bristol, lad? And I said, David, I came to the University of Bristol.
Was he also Paul McCartney?
In disguise? I don't think so. I said, no, David, I came to the University of Bristol for a PhD and to work with that woman over there. And I was pointing to Emily, and she stood in the corner of the room. And he said, oh, well, it is a lovely university, isn't it? And I said, yeah, David, it's great.
Aw.
Yeah, really sweet guy.
Yeah, no, all I'm doing is, every single dinosaur knows, oh, you've done pliosaurs. Well, can we talk about pliosaurs just for a little bit? Because although they're not dinosaurs, technically, I'm still interested. So can you tell us anything? Because Dave always stays away from marine reptiles.
Yeah, because I don't know anything about them.
Exactly. Do you know stuff about pliosaurs? Can we ask you a bit about pliosaurs? Like how big they got, what they were eating when they were around, that sort of thing? Because that would be cool if you know anything. If you don't, it's fine. But,
I mean, I know a little bit about them, but that was supervisory work for ichthyosaurs that I did. When my first master's student was looking at ichthyosaurs. Yeah. She was comparing different skulls of these strawberry bank CT scans we had. There was one with a really long rostrum. There was one that was kind of shorter skull, but she was doing FEA in conjunction with Mike Benton and Ben Moon. And we got that published in Journal of Anatomy. It was cool. But that's about as far as I've gone with marine reptiles. Very cool animals. I'm surprised that the UK doesn't have more funding to work on them, because they're kind of a national landmark, I think. But
yeah, we've got so many. I mean, we could do with more funding for just about everything in paleo. I think it's the standard problem of them not being dinosaurs, and so it just doesn't attract people in quite the way that it arguably should. But I'd also say you see that in other places, like Germany at the moment basically doesn't have any pterosaur researchers, and this is still like the home of the Solnhofen. There are certainly, at worst, it's the 3rd best country in the world for pterosaurs, behind China and possibly alongside Brazil. And then he's just head and shoulders above absolutely every, 1, 2, 3, and then dig for a couple of weeks to get down to everyone else. So yeah, the fact that they have none with their research tradition is just absurd. But I think it's just the way these things swing. Because you mentioned Ben Moon, but there was him and Tom Stubbs and Adam Stewart Smith and Richard Forrest. There were quite a few people, and Mike Taylor, the other Mike Taylor, all around at the same time. And then, as usual, people have just kind of drifted out of the subject.
Yeah.
And then there's no replacements come through. And so you've hit a bit of a lull. And it's actually, that's probably similar for pterosaurs in the UK. Because you had, when I was doing my PhD, or just after, you had Darren Naish and Mark Whitten and Mike O'Sullivan and Lorna Steele. So you had a real raft of us. And then, Darren and Mark are still active, but I'm probably the only one who's got an academic job, and even then not really doing pterosaurs. So yeah, you went from this raft of like the most PhDs in pterosaurs we've ever had to no one has really got an academic job as a pterosaur researcher, and it's just faded again.
Well, the thing is, Dave, you mentioned that the issue is that it's not dinosaurs, but I don't see a whole lot of funding for dinosaurs either. I mean, in particular.
Yeah.
So I guess it leads into what I do. I mean, it seems to me like the money is all on mammals, extinct mammals.
Yeah, but also, just number of people. If you just don't have many researchers, they're not going to get the funding in. They're not going to have the postdocs and the PhD students. And I was thinking about it earlier actually when we were building up to this, because of course I'm ex-Bristol as well. We interviewed Mike just a couple of months ago, and I was thinking, like, actually, Bristol is a big centre for paleo, but I think it's not like it's giant. People need to be aware. It's not like Bristol Paleo Department is some 10-story building packed with vertebrate paleontologists. And yet, I would say probably between the east coast of the US and Beijing, Bristol is the city or research institute with the most vertebrate paleontologists. And yet, there's 5 or 6 academics, because that's how sparse paleontology actually is. So yeah, like across half the globe, the biggest research institute has half a dozen academics, couple of dozen maybe PhD students and postdocs total. That's it. It's like 30 people. It's a small field.
Yeah, it really is.
Say something positive, someone, for goodness sake. We've got loads of people listening to this. This is the most depressing.
It's just what you get for having me on. Yeah, it was the best when I was talking about getting drunk. That's when it was at its peak.
Can see you now while you are getting drunk. Yeah.
I wish. I did have 2 White Russians before this. I didn't want to say anything, but I thought it would ease me up a little bit. No, I was going to say mammals. The thing with mammals is that I've noticed they got funded more recently, and that's actually what I'm working on right now. Actually, like that's what my postdoc funding currently is. So I'm
extinct or extinct mammals?
Extinct. So these are extinct. Technical term would be non-mammalian cynodonts, because they don't have, they're not quite modern. They're kind of this weird extinct subvariety. But we've been using a lot of synchrotron work to study them. So I've been spending a lot of time at these big X-ray synchrotron facilities. So there's 2 of them that I've been going to. There's Diamond Light Source, which is in Didcot, Oxford. So this is where we do a lot of our synchrotron stuff. But then the other one is the European synchrotron facility in France. So we take a lot of our samples. We have tooth samples we've been looking at. We've been looking at dental tissues and reconstructing basically like the life histories of these extinct mammaliforms. This is another paper that we're kind of in the middle of, so I can't go into too much detail, but that's what a lot of my time has been, is kind of reconstructing life histories and extinct mammals.
And a synchrotron is a bit like a Hadron Collider, isn't it? It's like a big circle building thing where they fire stuff and you can see it. I don't understand it. But is that what it is? Is that what I'm thinking of? Am I thinking correct?
Yeah, it's basically just a giant thing of machinery in this room that you have to safely exit because it gets filled with radiation. And I remember asking him once what happens if I stick around, and I don't remember what the answer was. I think I just mentally blocked it out because I was exhausted. But I imagine it wouldn't be very good.
I once asked my friend Rebecca to ask Brian Cox what would happen if, Professor Brian Cox, what would happen if you put a kitten inside the Large Hadron Collider. And the answer is it'd become super massive, but live forever.
Wow.
Actually, if you sent it round. Yeah, right.
Yeah, because if you could do that, it would just get bigger and bigger and bigger, and also not change because time would be going really slow for it. Which, giant, massive kittens. That's a good.
I think that happened on Rick and Morty. Yeah, that's my favorite episode.
Nice.
There's and Andre will miss this reference entirely, and I only know it because I've seen the repeats. The Kitten Kong from the Goodies back in when would that have been? Early 80s,
70s.
70s, yeah, quite. So
amazing.
Yeah, before my time as well.
Before we start doing the funky gibbon, shall we?
Yes, there is a place to end it.
I mean, beautiful. Well, can't wait for your research on weird, non-weird mammally type teethy things. That sounds freaky. So well done. It's an absolute pleasure to meet you, Andre. Do you have any social media or YouTube or anything that people can follow you, or are you just too cool for school and you don't need the followers?
I like Instagram. I think Instagram's cool. I can look at tattoos and metal bands and other cool things.
Nice.
I think my handle is Tyrannosaur Rowe, last name Rowe. Very original. And then that's about it really. I'm on Twitter. I don't use it because I don't really support billionaires, but
we've moved on to Blue Sky. Don't worry.
Yeah,
you and everyone else.
But it's been utter pleasure. Thank you for disagreeing with Dave. I like the idea. I think you should go with it. I've seen leopards do that. They jump down off trees and just get things like in one go. So I reckon
jumping down off trees is something different for T-Rex. That's a whole separate hypothesis.
They could have done it. They could have done it. That's one thing. There must have been like high ledges, and all they do is they jump down and jump on something and bite it once it's dead, thrash it around a bit like a dog with a squeaky toy. I like this idea. Better than plodding slowly behind them, Dave. It's much cooler. All right, then. So if you don't know, Andre, at the end of every episode, we do the most scientific and best thing that we could possibly do, which is we basically say rawr at the end. So if we could, after 3, we're going to do our most wonderful, proper Tyrannosaur growl and rawr to say goodbye to everybody who's been listening. So after 3, 1, 2, 3.
He's quite
Perfect.
good at this.
That's good. That is,
Lovely.
He's done that before. Thank you for listening to this episode of Terrible Lizards, and thanks as well for going to that social media you never seem to update and sharing the podcast there too. You could also go to patreon.com/Terrible Lizards to support the show and access a wealth of extra content. Get in touch with us via terriblelizardspod@gmail.com, and while you're here, do check out Dave and Izzy's books. Flappy bye-bye.